Welcome to a combined lesson on the periodic table, transition metals, and water. Now, let's just say, because obviously, as the way this bizarre method of Mr. Howe's works, I need to find something that can be used to truly represent the periodic table. But I'm honestly not quite sure what to use. Aha! Let us say that this bench is the periodic table. Over here, you have the metals. Then when you get here, you have our non-metals, and down here, this mouldy cloth represents the more radioactive elements that are not represented in the normal periodic table. Now, Now all of the elements are listed along here. I'm not a freak, honestly. Along here. They go in order of their atomic number, which will be listed on the bottom as opposed to the mass number on top. So as it goes along, it increases, stops, starts again, and this continues a bit. However, there is further organisation of the elements into groups and periods. Periods come across as represented by this plank. Now, all of the elements on this plank, their atoms will have the same number of electrons, the same number of electron shells as the other elements in their table. Now, furthermore, there are groups that go from the top down to the bottom, as that pole beautifully represents. Now, every atom in the group has the same number of electrons on their outermost shell. So, let's say, for example, hydrogen, as a simple one. It's 1, 1. So, it's in period 1, 1 electron shell, and group 1, as it only has 1 electron in its one shell. Yeah, that makes sense. As a note, atomic number, which will be on the bottom, is determined by the number of electrons or protons that are in the atom. Which is quite simple when you get down to it, isn't it? Okay, so now it's time to talk about transition metals. Transition metals are found in the middle of the table. They're just before you get to the non-metals at this end, but they're not the real metals down this end. They're just in the middle. They would include things like zinc, silver, etc. And there's nothing really. They're not particularly reactive or anything. And I can't honestly remember what I've been taught about them, so I can't say much more. And now it's time for what I've been experiencing all day via this rain. Water. Let's go find some water. Here, can you see this on the camera? Look, there. Wait. As you can see, there is some water. Now, water is what we drink and rely on to survive in multiple forms. We need it obviously for our body functions to function. And anyway, water, as you can see, this water is mank. It's filthy, it's dirty and vile. And so, it needs to be cleaned before we can do so, before we can drink it. Now first, so there are several stages to making water drinkable for us, as represented by this little course I've set up here. So here, my hand is water. As you go along, and as you go through the first barrier represented by the hedge, it's called sedimentation, where large things that don't need to be in the water are removed, such as this rock, which then goes, and the water carries on. Having had all larger bits removed, then you have filtration, which is much better, and can remove the much smaller bits of dirt or anything that you would have. And now, lastly, as represented by this drain, you would have chlorination, where let's say that these bars represent the chlorine that would kill anything that comes in that's bad. For example, as shown by how this water, as you can see, is dripping in, whereas it's not that easy for other things. As you may have seen, I just spat on the floor. and it wasn't able to get through, as represented by chlorination. And here you have all these chemicals that don't get in, because chlorination absolutely kills them and destroys any microorganisms that are there. And so, this concludes my session on C4. Thank you for listening, viewers, and I shall see you next time.